Hi students, here is Sushri Priyadarshini, lecturer in Mechanical Engineering from Bose Katak. Today I will teach you today is the third class of air compressor. In this class, I will cover the remaining content of our syllabus. In the first and second class, I have covered some portions of our content. Let's go to the content page. So, in the first class, I have covered the function of air compressor and industrial uses of compressed air, and also I have covered the classification of air compressor and the principle of operation of air compressor, and also I have covered the terminologies of reciprocating air compressor, and also I told you about the different parts of air compressor. So today in this class I will tell you what is the working principle of reciprocating air compressor. Okay, and I just want to remind all of you, in the air compressor part we have already studied about the different parts, that is valves for piston, cylinder, motor and other arrangements. I had told about multi-stage air compressor, the intercooler part, okay, and single acting, double acting air compressor. These are the terminologies of air compressor I told you in the previous class, and I had already cleared about the construction of air compressor, how the parts are arranged and how it works. But today I will discuss about the working principle of reciprocating air compressor. Okay, so let's go to the working principle of reciprocating air compressor part, and I will tell you the points and I will definitely explain you, and after that we'll derive the work done formula of reciprocating air compressor. Okay, so first, as the piston moves downward from TDC to BDC, any residual compressed air left in the cylinder from the previous cycle expands first. Actually, what happens in the air compressor, first, I am telling you, that is piston and cylinder arrangement is there, and when the piston is moving downward, suppose this is the cylinder and inside that piston is moving, and I had mentioned this is BDC and TDC, okay, and when the piston is moving downward, that is from the top dead center to the bottom dead center, then what happens? Above the cylinder head, there is some part of air from the previous cycle is remained inside the cylinder. Okay, so that air, that is a compressed air part, and that is remained from the previous cycle, clear? That will first expand. Okay, that air will expand first, expands, because when it is moving downward means this air, initially this air was compressed by the cylinder, by the piston, and when it is moving downward in the towards the BDC, okay, and this air will expand in this region inside the cylinder, clear? Then after that, what happens? On further movement of the piston, the pressure inside the cylinder falls below the atmospheric pressure. That is most important. When the suction process will start, when the pressure inside the cylinder will be below the atmospheric pressure, that means outside the cylinder there is the pressure maintained is called as atmospheric pressure, and inside the cylinder there is certain pressure. Then when the piston is further moving downward, first expansion will start for the air which is remained inside the cylinder. On further movement of the piston, then what happens? The pressure gradually decreases below the atmospheric pressure. Okay, and when the pressure decreases below the atmospheric pressure, then what will happen? The air will rise from the high pressure to the low pressure. Okay, then what happens? The atmospheric pressure pushes the inlet valve to open. Okay, and there are two valves was there. I told you in the previous class what is inlet valve. First is inlet valve and another is outlet valve. Okay, inlet valve and outlet valve, and inlet valve will move open inside the cylinder. Okay, in this direction the inlet valve will be opened and the outlet valve will be opened towards the outward direction. Okay, so through this inlet valve, when the atmospheric pressure will be high than the pressure of air inside the cylinder, then the high pressure air will push the inlet valve. Okay, push the inlet valve. At that time the inlet valve will be opened. When the inlet valve will be opened, then fresh air from the atmosphere will rush into the cylinder. That process is called as suction. Okay, suction is created inside the cylinder, and at that time the outside air, which is having pressure higher than the pressure inside the cylinder, that will rush into the cylinder by opening the inlet valve. Inlet valve will be opened. Okay, the atmospheric pressure pushes the inlet valve to open and the fresh air enters into the cylinder. This is most important part. Point by point and one by one you have to understand, you have to remember. First part was the piston moves downward from TDC to BDC. First, the expansion of the air which is remained inside the cylinder will happen first. Then second part is after the further movement, the pressure difference will be created. That means inside pressure will be lower than the atmospheric pressure. That leads to suction, and after that the atmospheric pressure pushes, the atmospheric higher pressure pushes the inlet valve to open, and when the inlet valve will be opened, the fresh air enters into the cylinder. Okay, so I will show you the diagram. The line 4 to 1 represents the suction stroke. I will tell you. During this stroke, the compressed air in the storage tank acts on the delivery valve. Okay, what happens during this stroke? The delivery valve, that means outlet valve, will be remain closed. Okay, the outlet valve remains closed. Then as the piston returns from BDC to DDC, the pressure in the cylinder increases and closes the inlet valve. What happens when the cylinder piston moves in the upward direction? First it moves in the downward direction from the TDC to BDC, then suction is created inside the cylinder, then outside air, atmospheric air into the cylinder, and after that, and at that process, during that process, the outlet valve is closed. That's why the air cannot skip the cylinder, they cannot leave the cylinder. Okay, only inlet valve will be opened, and due to the suction process, only in this direction air is entering into the cylinder and nothing is happening. Okay, then after that, when the piston is moving in the upward direction, okay, because the piston is moving in one revolution. Okay, first it is moving in the downward direction, and after that when it is moving from BDC to DDC, the air inside the cylinder is getting compressed, okay, by the piston. The air inside the cylinder which is remained in the cylinder is getting compressed by the piston. And what happens, and this compression process will lead to closing of the inlet valve. At that time it closes the inlet valve, okay, because there is no pressure difference is there. It is compression happens, means this pressure is increasing and atmospheric pressure cannot rush into the cylinder. That's why this valve will remain closed. Clear? And I am showing you the graph. Okay, this graph. Okay, this is the process of working principle of air compressor, and in this process the all the strokes are happening. First is suction, then compression, and this is the delivery. That means that this is the discharge, okay, of the air into from the cylinder to the storage tank. Okay, so I am telling you about this suction line. What happens during this suction process? during this suction process, 4 to 1 line is the suction process, and during this process it happens at which pressure? At this pressure, constant pressure, at this pressure P1, clear. Then during this suction process air is entering into the cylinder, okay, and up to which point? Up to this point, okay. And you can clearly see the volume is also increasing, because what happens, air is entering into the, air is covering the volume, air is entering into the cylinder at constant pressure, okay, and up to one point the suction process is happening, and after that what happens, piston is moving upward direction, in upward direction, and that compresses the air which is which have entered into the cylinder from the atmosphere, and during that compression process, you know that this is isoentropic compression process, and during this compression process what happens, you know, in the during the compression process volume decreases, and volume from the volume B1 up to volume B2, clear. During the compression process 1 to 2 is the compression process, and during this process what happens, volume decreases because the piston is compressing the air, volume decreases, and what happens, pressure increases. What is the pressure? Pressure increases up to which pressure? P1 to P2 pressure, clear, P1 to P2 pressure. Up to 2 point the compression process is happening, and after that what happens, I am telling you, after that as the piston returns from BDC to DDC, the pressure in the cylinder increases and closes the inlet valve, that is the compression stroke. And during the compression stroke, as air pressure reaches a value which is more than the pressure of compressed air, delivery valve opens. What happens? This is most important, try to understand. Okay, during the compression stroke, that means during that particular stroke, the, three types of processes are here: suction, compression and delivery discharge. As air pressure reaches a value which is more than the pressure of compressed air, okay, air pressure and inside the pressure is more, okay. When the inside pressure is more, because of compression process pressure is increasing and pressure inside the cylinder is getting higher, and when the inside pressure is more, the delivery valve will open. I told you delivery valve will open towards the outward direction, okay. So delivery valve will open. When the delivery valve will open, that what will happen? The compressed air is discharged from the cylinder to the storage tank. That means compressed air is inside the cylinder, okay, which is having a very high pressure, and that high pressure compressed air will be discharged from the cylinder to the storage tank. Why storage tank? What is the purpose of storage tank? The purpose of storage tank is to store the compressed air for the further use, industrial use. Okay, we need to store that storage compressed air in the storage tank, otherwise it will be expanded and it cannot be used. So from the delivery valve to the storage tank it will be discharged. That is also a process, and that happens at the higher pressure, that is at the P2 pressure. I have shown you in this diagram, in this graph, okay. Up to this point, compression will happen from 1 to 2. Okay. So during this compression process, what will happen? When the air pressure is getting higher and pressure is increasing, after that the delivery valve will open, and 2 to 3 process is what? 2 to 3 process, discharge of the air to the storage tank. Discharge of air from the cylinder through the outlet valve to the storage tank will happen. Okay. Then I am showing you the process. These are the processes. First one is process 4 to 1. 4 to 1 means first 4 to 1, that is suction stroke. Okay, suction stroke, inlet valve opens and the air enters into the compressor at pressure P1. You need to understand this is the suction process, process 4 to 1 in the PV diagram, and then process P to 2, that is polytropic compression process of air from P1 to P2, polytropic compression of process of air from P1 to P2. Sorry, I mentioned that is isoentropic, but it is polytropic compression of air from P1 to P2. Then process 2 to 3, discharge of compressed air through the delivery valve, that is the process 2 to 3 at that happens at which pressure, that is P2 pressure, and this happens at pressure P1, clear. Then process 3 to 4 means return of piston for the suction stroke, that is not the process, okay, only returning of piston for the further next cycle, for the next suction stroke the piston returns, but these are the processes for suction, okay, that happens at particular pressure, that is P1, then process P to 2, that is compression process, polytropic compression process, then process 2 to 3, that is discharge of compressed air through the delivery valve. These are the processes of what? Air compressor, okay, and I am telling you about single acting, okay, without clearance, I am telling you without clearance, okay. Then coming to the previous slide, compressed delivery valve opens and the compressed air is discharged to the cylinder from the cylinder to the storage tank. At the end of compression stroke, the piston once again moves downward, okay, and the pressure in the cylinder falls below the atmospheric pressure, delivery valve closes and inlet valve opens, that is for the next cycle. That means at the end of when the compression stroke will be completed, after that piston once again moves in from the top dead center to the bottom dead center, and during that process the pressure inside the cylinder, again the pressure inside the cylinder falls, reduces below the atmospheric pressure, and during that process what will happen, delivery valve will be closed and the inlet valve will be opened, and again suction will be created, atmospheric pressure will be entered, and again piston will move upward direction and compression process will happen, okay. In this cyclic process this air compression is getting completed, okay. The suction, compression and delivery of air takes place with 2 strokes of the piston, okay, with 2 strokes and in one revolution, 2 strokes are there, all these processes are completed in 2 strokes and 1 revolution of the crank, clear. Then coming to the next slide, okay. Now I will tell you how to calculate the work for a single acting compressor without clearance, and this is the PV diagram. From this diagram we will understand how to calculate the work done for a single acting compressor, air compressor without clearance. See this diagram, in this diagram I am telling you 1 to 2 process is the compression process, and this is the what, suction line, and this is the discharge line. We have to draw another diagram, that is first this one, this is what, this line 2, 3, and suppose this is O, this is A, okay, this is 2, 3, O, A, and what is the pressure value, this is P2, and what is the volume value, though this is the 2 line, the volume will be at this point, the volume will be V2, that means this is V2, and what is the net work done, this is P2 and V2, clear. And then another line is there, indicator diagram, this is this diagram, okay. That means it is 1, 4, O, suppose this point is B, this is B, okay. And what are the parameters, this is P1, you know that this much pressure, that is P1, and what is this volume is V1, because this is 1 point and at this point the volume is B1, volume is B2. Air is getting compressed from volume B1 to B2, from 1 to 2 point in this direction. Clear? So, this much is, what is the work done? P1 and B1. Clear? And we need to find out this amount of work. We need to find out this amount of work. Clear? And to find out this amount of work, we have to calculate the individual work done. That means, this is the 1 to 2 process, this is polytropic compression process, polytropic compression process. And what is this work done area under this curve? What is this work done? How it will be calculated? Like this, like this. This is 1 to 2, this is compression process. Suppose Pb to the power n is equal to constant. Okay, polytropic process, Pb to the power n is equal to constant. This is the work. Clear? When we need to find out this amount of work, we have to first add this work to this work, and after that we have to subtract this amount of work. That means, to find out the net work. Net work is what? Net work is the work that is 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. This is our need. Okay, this is our requirement. To find out this amount of work, we have to do what? First, 2, 3, O, A2, area of 2, 3, O, A2, this amount plus area of 1, 2, A, B1, 1, 2, A, B1. Okay. Then minus 1 minus area of 1, 4, 1, 4, OB1, OB1. Okay. That means, first this area 2, 3, OA2, this will be, this area will be added to this area and will subtract this area, and after that we will find out 2, 3, 4, 1, 2. Clear? This is our aim. So, how we will derive? First, area of 2, 3, O, A2, 2, 3, O, A2, that is P1, B1. I told you that is P1, B1. Okay, P1, B1. Sorry, that is P2, V2. Okay, pressure is P2 and volume is V2. P2 into V2, and then area under this curve, polytropic compression process. Okay, that means P2 V2 minus P1 V1 divided by n minus 1. You know the work done for the polytropic compression process. Though it is the compression process from 1 to 2, P1 to P2, that is why the work done process, work done formula is P2 V2 minus P1 V1 divided by n minus 1, which is derived from the integration of PDV. So, minus, what is this work? This work, that is P1 and V1, P1 into V1. And what is the final formula? That is P2 V2 minus P1 V1. You need to arrange P2 V2 minus P1 V1 divided by n minus 1. Clear? Okay. P2 V2 minus P1 V1 plus P2 V2 minus P1 V1 divided by n minus 1. Then what will happen? We will take common, that is P2 V2 minus P1 V1 divided by n minus 1. Okay. I will take common P2 V2 minus P1 V1, then 1 plus 1 by n minus 1. Clear? Then what happened? P2 V2 minus P1 V1. I will simplify this by taking LCM n minus 1. So, n minus 1 plus 1 cancelled, that is n by n minus 1 P2 V2 minus P1 V1. Okay. This is the work done for the what? Single acting air compressor without clearance. Here we are not considering any clearance volume, without clearance. Okay. So, then again we will simplify the formula n by n minus 1. This is PV, you know PV is equal to MRT. So, P2 V2 is equal to MRT2 and P1 V1 is equal to MRT1. Mass will be common because mass of air, this is mass of air R into T2 minus T1. Okay. I hope you will understand this. N by n minus 1 is whole into MAR, M will be common, R will be common, but temperature difference is there, whole into T2 minus T1, and after that n by n minus 1 MAR, if I will take T1 common, then T2 by T1 minus 1. Clear? This is the again further simplification, that means that is n by n minus 1 MAR T1 whole into T2 by T1 minus 1. And what is the for the P to the power n is equal to constant, polytropic process, that is T2 by T1 is equal to P2 by P1 to the power n minus 1 by n. T2 by T1 is equal to P2 by P1 to the power n minus 1 by n. So, in the place of T2 by T1 I will put the value n by n minus 1 MAR T1 whole into P2 by P1 to the power n minus 1 by n minus 1. Okay. So, this is the work done formula for the air compressor without clearance. Again if you have to substitute P2 by P1, what is the P2 by P1? That is RP. In the previous class I told you about the pressure ratio. Pressure ratio, what is pressure ratio? Pressure ratio is the ratio of air after the compression and the before the compression. After the compression pressure is P2 and before the compression pressure is P1. Okay. So, and that ratio is RP. So, in the place of P2 by P1 you can write n by n minus 1 MAR T1, that is RP to the power n minus 1 by n minus 1. You can write, this is the work done. Okay. And this work done formula you can place, you can again write n by n minus 1, here you can write P1 B1 MAR T1, that means that is P1 B1 whole to the power RP to the power n minus 1 by n minus 1. Again you can write also like this. That means in the problem, in the question, if initial temperature value will be given and mass is given and R value we can take for air and Rp value is given, you can find out the total work done value for the air compressor. And suppose if the volume is given, initial volume is given and initial pressure is given and pressure ratio is given, then also you can calculate or find out the work done value for the air compressor. Okay. So, these are the multiple formulas you can find out the work done value for the air compressor. This is the derivation of work done for single acting air compressor without clearance. Remember, without clearance. So, here we are not taking any amount of clearance. Okay. I hope you all can derive this formula and you can solve the problems which will be given in the question. Now, further I am telling you. We will study about different powers and efficiencies. What are the different powers which is associated with this air compressor and what is the efficiency. Okay. And first one is indicated power. First one is indicated power. Okay. And in the first class I was telling you about the indicated power and brake power. What is the indicated power and brake power? You must have remembered in IC engine part, the first is indicated power, because in the IC engine the combustion process will occur and piston will move, then crankshaft will rotate, reciprocating motion will be converted into rotary motion, and that power which is available at the crankshaft is called as brake power. Okay. But in the air compressor case, first we have to provide the work, provide the electricity or provide the some work to the motor. Okay. We are providing electricity to the motor and motor is running and the prime mover that is connected with the air compressor, shaft is connected with the air compressor, and due to the motor the piston is reciprocating, and after that air compression of air is getting take place. So, first motor part, that is shaft is rotating, and after that the piston is reciprocating. That means the brake indicated power, the work done on air per unit time is called as indicated power input to the compressor. Okay. The power required by an compressor running at n RPM is given as indicated power, that is work done per cycle into number of cycles per unit. Okay. And what is the formula? That formula is Pm into L into A into N into K by 60. This is Pm into L into A into N into K by 60. And what are these parameters? That means from the brake power means when the prime mover is running, the power available at the crank that is called as brake power, and after that piston is reciprocating, that means that work done on the air take place, because we are compressing the air is getting compressed by the piston, that means some work is done on the air. Okay. So, the amount of work which is done on the air is called as indicated power. And how you will find out the which amount of work is done on the air, that is Pm. Pm is the mean effective pressure, then L is the length of stroke length, I told you in the previous class, then A is the area of the cylinder, that is pi by 4 d square. Okay. Area of the cylinder, d is the diameter of the cylinder, then n is the number of revolutions per minute RPM, then K K, what is K value? K is, that means number of inductions. Okay. In the previous class I told you about the single acting air compressor and double acting air compressor. That means in single acting air compressor, the compression of air takes place at one side of the cylinder. In that case the K value will be 1. When the single acting air compressor, we are taking the single acting air compressor, then K value is 1, and for double acting air compressor the K value will be 2. Okay. You have to take accordingly the K value, whether it is single acting or double acting, and PM is the mean effective pressure. Okay. And L is the stroke length, A is the area. This is the formula for indicated power. Okay. So, divided by 60, though it is revolutions per minute, that is why it is divided by 60. Okay. Then next is brake power, the actual power input to the compressor. That means this is the brake power, which is, that is the power actually input to the compressor, but some part is lost due to the friction. I told you about in the previous class, some part will be definitely lost due to the friction. So, and that by subtracting the frictional power from the brake power, the net power which we are getting, that is called as indicated power, and this power is actually doing the work. This power is actually work done on the air. Okay. This is, we are supplying the brake power, we are supplying the actual power input to the compressor. Initially we are supplying which is more than the indicated power. Definitely it is more than the indicated power, because this is the actual power input, but after that this frictional power will be lost due to the frictional action, and finally this indicated power is working on the air. Okay. And this indicated power, due to this indicated power, compression process is happening. So, brake power is equal to this indicated power plus frictional power. That means that indicated power, that is equal to brake power minus friction power. Okay. Frictional power is brake power is the actual power which we are providing, frictional power which is lost due to the friction, and indicated power which is the final power which is acting on the piston for the compression process. Okay. So, these things you need to understand, what are the different powers. Okay. And brake power you can calculate by by putting the formula 2 pi mt by 60. Coming to the efficiency part, mechanical efficiency of the air compressor, it is given. Okay. So, mechanical efficiency, that is equal to indicated power divided by brake power, because you all know that when we are calculating the mechanical efficiency, the output divided by input, and in this case, in this air compressor case, the input is the brake power. We are providing this amount of power, and we are getting this amount of power after the lost due to the friction, and this power is responsible for the compression process, and this power we have provided initially. That is why this mechanical efficiency will be, output is the indicated power and input is the brake power. So, indicated power divided by brake power is equal to mechanical efficiency. But in the IC engine case, the reverse is there, the mechanical efficiency is brake power by indicated power. So, do not be confused. In this air compressor case, mechanical efficiency is equal to indicated power divided by brake power. So, this much. So, okay. So, we have covered the working principle of reciprocating air compressor and work done for single stage compressor without clearance. Okay. And also